Well, what I have here is a Heathkit model IN3117 Resistance Decade. It's an attractive unit. It's in good shape. I've been cleaning it up and doing some repairs on it. And right at the moment have been working at trying to reduce my low-end ohms to the minimum. Probably the most important task because contact resistance, wire resistance, switch resistance, all of those things become an issue at extremely low ohms. And I think I've been fairly successful right now. I'm reading about 7 thousandths of an ohm. On my fluke, 6, 7, somewhere in there. And in the process of correcting the issues, you'll be able to see that I did some repairs. I replaced some 2-watt resistors. This would have been on the thousands. Here on the ones, I had a couple of them that were bad. Hand selected the resistors. Some cases had to parallel some in order to get the resistance I wanted, but that's good because not only do you get that resistance, but you get additional current carrying capability. The precision was maintained throughout. That was the whole goal. Cleaned up the switches, and I'm about ready to make a test here, so bear with me a moment and we'll do that. Okay, so what I'm going to do to test this thing is I'm going to measure the resistance at each step, record it, then I'm going to put it on a spreadsheet and we'll do an analysis to see how we stand. Right now I'm reading 0 on the Decade resistor and I've got 0.009 ohms, which I've recorded. Then we're going to go to step 1. This is 1 ohm. We got 1.00, I'm going to call it 9. 2 ohms. 2.005. 3 ohms. 3.009. 4 ohms, 4.008. The low ohms are the most critical. They're the hardest to get the error right on these boxes, and that's because of all of the additional low resistance factors. 5.008 in contact resistance, wire resistance, switch resistance, and so on. 6, I've got 6.01, I'll call it 2. 7.006. 8. 8.006. 9. 9.007. 8 maybe. 9.008. And then we would begin the next decade. We're back to 0.009. Yep. A little flash, but 9. 0.009 ohms again, and we go to first step. This is a 10 ohm step. We got 10.042. Alright, I'm not going to make you suffer through watching every step here, but I am going to make you trust me that I record them properly. I'll do that, and we'll do the analysis, and I'll present the results. 20 ohms, I got 20.077. Get back to you in a few minutes. Okay, so I've transferred all of the readings to a spreadsheet, and we have the column with the multiplier. That's the resistance range. So you got the ones, the tens, the hundreds, thousands, and so on. And across the top from left to right, you got the multiplier. That's the actual dial, so setting. So you've got 0 through 9 on the dials. So if I was on the ones, I would go to the multiplier of 1, and then I would look at 0 through 9 for the steps, right? So then at 0, I had 0.009 ohms, and you really want to get 0, but you can't on the really low ohms. At least I can't. There are resistances within the wires, within the contacts going to the meter. You've got an offset possibly in the meter itself. But knowing that you have that 9,000ths of an ohm reading and that it carries through every step, if you back that initial reading out, then you get a truer picture of the tolerance of all of the resistances themselves. So I have it with the 0 reading. That says error in the yellow bar. That includes the 9,000ths resistance. And we see that there's only one position where we are out of the 0.5% tolerance, and that's at the very, very lowest setting. That would be 1 ohm itself. If you include that 9,000ths of an ohm resistance, we are 0.9, so we're under 1%. All of the rest of the settings are under 0.5, which is what we're shooting for. If you back out that 9,000ths of an ohm at every one of those positions, you get a 0 backout error, I call it, and that's in the white. And you'll see that the tolerance changes quite a bit. In fact, that 1 ohm step becomes 0. 2 ohms becomes 0.2%. So we are actually quite good. The worst position in the entire box is 0.42%, and that's at 3 ohms. I'm sorry, that's at 30 ohms. Every other position is well within 0.25%, it looks like. So I'll include this on the sales documentation as one of the photos, and for your review. Okay, so here's the happy moment. We get to get a look at the enclosed unit. It's a very attractive Heathkit IN3117. Good shape. There we go. We have a minor scratch across the back here, as you can see. Paint's in good shape. Rubber feet are intact. Screws are in place. And as we've seen, the results indicate that we are well within tolerance. It's a beautiful unit. Very handy to have on a bench. I find them particularly handy when I'm searching for a bias resistor, or I've also done some filter work, especially in the audio ranges. This works quite well. RF, the parasitics kind of get in the way, but I have one myself on the bench. I think you'll enjoy having one too. So thank you for listening. Happy bidding.